Hello, everyone. Welcome to MATHurdays. Math's so fun, we do it on Saturdays. And in the chat box there, I've posted the link for today's slides. The way that I do this session is that most of our time is spent in the Google Slides, editing, adding, and having a voice. Sometimes we'll move over to the teleconferencing tool for things like the microphone and chat box. You'll notice in a few minutes I'll turn off my video because we're just going to use the slides for almost everything. On this first slide, I have links to my email address, website, Twitter, and YouTube channel. I try to stay pretty active on all of these. I also have a link to a book that I wrote called Teaching Math at a Distance, where it incorporates many of the things that we're going to do today. On slide 2, I have links to some things that you might want to bookmark, including templates. And folks, if you are used to this, I have a bunch more coming in this weekend. I've had kind of a stockpile and just need to get to actually bringing them on. And the other link is for MATHurdays. And I currently have over 30 math tasks with a routine and a complete guide to how to do this in the online classroom. And today is the by next week we will have a full year of these. So a pretty amazing group of people that come to these. And then I would love to hear from you all, where you're coming from, what successes you have, what celebrations you have. Here's the link to the slides again, and come on down to slide 3 or 4 and share with us a success or a celebration that's happening with you. You can use the text box to do this, but please feel welcome to add images, pictures, GIFs, emojis, bitmojis, and more. This is totally unstructured for us. And those of you who are regulars, welcome back. If you're new, welcome. So glad to have you here. Last weekend, I was the tech support for the Virginia Council of Teachers of Mathematics, which is why we didn't have a MATHurdays session. And I have a picture of my computer monitor with 10 different Zoom tabs open during 5 different meeting times, for a total of 50 presentations total. So I was quite busy last time, but we had a really successful conference. William, welcome from Maine. I invite you, if you'd like to go ahead and turn on your microphone and tell us a little bit about what you all are doing up in Maine. We have people from all over the States and Canada and really the world here, and it's nice to connect.
Thank you, Teresa. We're doing a book study of your book, and I was very impressed with your presentation to us. It was a wonderful modeling of what we aim to do. So I was very excited to join a MATHurday.
Awesome. Glad to have you here.
Thank you.
Some wonderful images coming on. I'm going to make this one image a little bit bigger so I can see what's going on here. But if you put that one, 3rd grade distance learning, I invite you to turn on your mic and just tell us a little bit more about this cool picture on slide 3.
Sorry, that took me a minute. I've been learning how to use Pear Deck interactive slides with Google Slides this year, and it is my first year teaching 3rd grade. So, and then doing it on distance learning. So that's what I've been learning this year.
How lovely. Awesome. Kathy from California. Well, you said you're going to have some students returning to in-person. You know, there's a lot of different terms going on out there, but does that mean that you'll be teaching, let's say at 9 a.m., some of your students virtually and some of your students in person?
It depends on the, excuse me, it depends on the school site. Some people have said that they want their students to say full distance learning the entire year. And so we're doing some in the morning in person and in the afternoon hybrid, but chances are we'll have most of them be doing morning and afternoon in person. So it's great. We finally hit the red tier and can get people back.
Awesome. Yeah, in the school district that I live in and my second and third graders go to, they're going to be doing a little bit of both. Some people are saying kind of, it's going to be ever changing depending on numbers and whatnot. So, so folks, what I'm going to showcase today is one of my favorite games. It's called Fraction Tracks. And we're also going to do a rich task. The idea behind what we do today is that students will talk more, participate more, and think more when they have a space to collaborate on. And so one of the big things that I like to try and disrupt is who is holding the marker. Because even in traditional face-to-face classrooms, there's sometimes one person who writes, and when that happens, the group dynamic changes. So here today, you're going to see that every single person can and has the ability to write on the screen, and then we can see each other's thinking as it goes on. So glad to have everyone here. Again, if you're new, welcome. If this is a repeated session that you come to, welcome back. And in the chat box there, I did put the link so you can access our slides. Raha, go ahead.
Good afternoon, Teresa. I just had a quick question. Did you also have laggy Google Slides for the past couple of weeks, or is it just me?
It kind of depends on the hour. There was a PD that I did 2 days ago at around 1 o'clock, and it was very laggy. But that could also just be our local area too. So not sure if and where that is.
Thank you. I appreciate that.
Yeah, no problem. All right, folks, so the math game that we're going to do is on slide 5. If you're looking for the single player mode, NCTM Illuminations has a fabulous little applet for it. It also works great if you have two kiddos sitting kind of like next to each other. But one thing is, if we're doing distance learning or social distancing in person, I wanted students to be able to see it on the screen. So in just a minute, I'll put you in breakout rooms where you'll have another buddy. This works great for 2 to 3 players. You start off by putting these little emojis on all the zeros, and then you hit the little play button. This little video will give you a fractional number, and you can move any increment. So if, let's say, you got 6/10, you could move one emoji to the 1/2, and you could move another emoji to the 1/10 because those added together equals 6/10. The whole goal of this is to try and get emojis to land exactly on 1, because when you do, that means that you have earned that chip and you can put a new chip back on 0 for start. If you need to take a look at the directions again, they are in the presenter's notes. They're also linked to Google Slides or to Google Translate in case you need to hear that again in English or your home language of choice. So let's get started right away. This is just a super quick. We'll spend 5 minutes in these little groups, and then we will come on back to the main room. So turn on your mic, say hello to your new friend, grab a slide and throw your names on it, and that can be yours to start. Here we go. Hi there, welcome Christine and William. Feel free to pick a slide below. We have so many blank ones. Put your name at the top of it, and then you all can play together.
All right.
Excuse me.
Hi there, group. How's it going?
Good. We just found our slide, so we're going to go ahead and start looking at this game here.
Awesome.
All right.
All right. Let's see.
All right, so place 7 emojis on the board, 1 on each row, all starting at 0.
So we put Does that include the 4 that's already there?
Yeah, I think
Someone
they were
else.
on there as like an example.
Okay.
So 1, 2, 3,
Hi there,
4,
Stephanie.
5.
Hey, group, you've got another person, just as a heads up. Stephanie just came. Welcome back, Stephanie. And William, or excuse me, which group am I in? What slide are you
5.
all on?
We're slide 12.
12.
Sorry I was late. I couldn't get logged in and I couldn't remember where the links were. So I was like, oh my gosh.
No worries. We
I
got a 3-player
apologize.
game here.
Well, Stephanie, we're on slide 12 right now if you want to. There
Right.
you are. All right.
There we go.
Should that be like player 1, player 2, player 3? Am I, or is it all just?
Okay.
I don't know. I'm asking.
Hi there, group 3. What slide have you all, or group, what slide have you all have chosen?
17.
Awesome.
So I just had a question on the right side where it says like player 1 chips, player 1 chips. Would that be like where the kids would put their name in?
Yep, indeed. Yeah, you can change that to be your name.
Okay, and that's fine. I was just we're planning a 6th grade math night, and as I'm looking at this might be with their parents, so this might be a fun one for them to do.
Oh, absolutely. And then if you want to make it like a double, you can make like one station where they are filling in the missing fractional pieces, because you'll notice that there's only some on here, and then another
Yeah.
they can actually play the game.
Okay, thank you.
Nice.
Left.
To move.
Oh, so then I can go to another number line and do 2/8 there.
Right. Or you
Okay.
can move that one back to the beginning and count your 1.
Mm-hmm. I'll move the little, let's see, 2/8. I'll do this little yummy emoji with the little yummy face onto 1/4, and that'll be my 2/8 right there.
Right. Now take
Okay.
now take and put, say that you get a chip
Mm-hmm.
up there at the top right. You can be, I'll be player 2. And you can
Okay.
be player 1.
So does the heart emoji then move over to that one because that's already one entire hole?
So then the heart one goes back to the beginning, back to 0.
Okay,
So who
got it.
won the heart?
I did. Good morning, Teresa.
Hi, good morning. Yeah, so if you won it, you actually get to put it over here in your winnings.
Oh, got it.
Oh, yeah.
Thanks.
Oh, and then put a new
And then you can
emoji.
put a
I
new
got
one on. Yep, you got it.
it. Okay.
I've got the little mask emoji. I got my second shot of the vaccine, so I'll do my little mask emoji.
And I'm rolling. Oh,
We can share for each one of us to get that to really make sense, I guess.
All right. Did you move? Okay, so the hard eyes move?
No, not yet. All
Okay,
right,
why
I
don't you
was
tell
told
what fraction did you
4/5
get?
again.
Okay, so you got, what fraction did you get?
4/5. Oh,
Okay,
I
so
see what you needed to follow to 4/10 and I clicked on the emoji.
Yeah. All right, so
So-
4/5.
I could just go down here straight to 4/5 instead of...
Yeah, right.
Oh,
Okay,
but
so-
are we only one or we can move more than one?
Well, you can move, like for 4/5, you could have moved like 2/5 and 2/5 if you wanted, or you could have moved 8/10 if you wanted. You have to, whatever you do, the total has to equal or has to be equivalent to 4/5.
Okay, I see. So this was the 5th line. And I could have gone 1/5 and then I could have gone...
Then you would have had 3/5 left over, so you could do like 6/10 if you wanted,
Got it. Okay.
because that's an equivalent.
Nice thinking, group.
Okay.
And this strategy will be even better for when the next person goes, because they're going to try and get one of those emojis to exactly 1. And when they do, they earn it in their little chip bucket.
Yeah. We have a question though. When you click on the YouTube video, it always ends on 4/10. So are you supposed to click and stop the video wherever you want, so that way you get a different
Stop it wherever you
fraction?
like. Yep.
Okay, that's what I thought.
Mhm.
That was good for me today. All right, because I always have that when I insert it. Now I get it. All right, so who's going next?
Teresa,
Mm-hmm.
Teresa, is it only the person who, like, we only see the video on our own screen.
Yes, unfortunately, it's
correct?
just on your own
Okay.
own screen.
Okay. Where you folks getting all these moves? Oh, so we're not taking turns. We're just kind of doing it randomly.
Yeah, so take turns. Who's next?
Right. That's what I thought. Okay. I have 1/4. All right. So I'm going to just move mine over. Where is it? I'm going to move it over.
I think I'm next one.
So that's the thing. We don't own any of the emojis. We can move any of them, the fraction.
Any of the one on the slider. And then once you get exactly one, it moves into your bucket, your point, and you put a new emoji back at the 0.
Right. But the thing is that shouldn't you be using the same emoji no matter where you move? Because in that way, you know who you are. Because, for example, when I have the kids play this in person, somebody will have a red chip, a blue chip, or orange chip. And what they're doing is, even though, let's say they might split up 4/10 and they might move it to one, theoretically, they might, if it was like 1/2, so they might move it to like 2/4 and then 4/8 or something like that. They keep the same chip so that they can see where they are, because you can move on multiple tracks at the same time.
Yeah, so this one is kind of the follow-up of that, where you don't have a red color, I don't have a blue color, we just have the emojis on here. And so you can almost like steal other people's, like you can try and collect a whole bunch in your turn.
Oh, so I could jump on somebody else's line and then with
exactly.
Oh,
that
okay.
gears
So
it up a little bit more, and it can make it more competitive for when your students need that like kind of extra competition.
Oh, okay, I like that. All right, so I can take somebody else's emoji and move it to get me to get a chip in the bucket. Oh, I like that twist. Okay, thanks for that.
Go ahead. Yes.
Hi group, how's it going?
I love this game.
Well, Piranha is beating us, as you can see.
What slide have you all taken?
15.
15.
Oh, 15.
Oh my goodness, look at all those ones there.
I know. What'd you get, Dan?
1/2. Again. Let's see. I'll move you here. Oop. All right, I'm good.
4 bits. So let's see. I guess I'm just gonna move this silly green thing over 4 bits. Wait a second.
Think about this one. Can you break it apart and get that
Wait
emoji?
a second. Okay, I'm gonna move this 1/10. So I can get it. And then I've got 7 more tenths to move. Oh,
So you take 1/10 and then you can take the 5.
I took 1/10. And now I'm going to move, oh, somebody moved one for me. Thank you. And I'm going to move this over 7/10.
That is exactly how you do it. Way to go.
Takes a little thinking, though. I did what my students probably would have done the first time they played.
I am teaching the fraction unit currently with my students, so I'm going to try this out.
This is going to be great for you next Monday.
1, 3.
I'm done, so go for it. Throw on up.
Yes. Okay. Yeah. Done. Dan, you can go and play.
All right, 2 8s. All right.
Welcome back, everyone. Hi there. We're all back together in the main room. I hope you had a blast with that game. And there are lots and lots of template slides below. I'll make sure you all have access to the blank slide also. But I hope you enjoyed fraction tracks and the twist with making the emojis and kind of having fun with that. That's going to lead us right into what we're going to do today for our task. So if you'd like to go ahead and join me down on slide 27. Each time before we dive into our rich task, I always like to give my students the opportunity to say this problem-solving oath. And if you would like to take the pledge today, you can type your name in the chat box. I, Teresa, promise to try my best. I will make sense of patterns and numbers. I will use manipulatives and drawings. I will make mistakes. I will ask questions. I will listen to other ideas. I will stay engaged by always trying to find another solution or representation. I am a problem solver. I make the world a better place. If you'd like to take that pledge today, go ahead and type your name with all the other problem solvers there in the chat box. And in today's activity, I have several virtual manipulatives on slide 28 that you might choose to use. I happen to think these are great, but they're not the only 5 out there. Use anything that works well for you. And your problem is on slide 29. It says, Julia and her 2 friends, Maureen and Sierra, decided to eat leftover pizza for breakfast. They took 4 pizza boxes out of the refrigerator and noticed that they contained different amounts of pizza. They found 3/4 of a pepperoni pizza, 4/6 of a cheese pizza, half a mushroom pizza, 1/3 of a sausage pizza. Describe at least 2 ways that the girls can share the pizza so that each kid gets a fair portion. And yes, that's vague on purpose. If you, I'll put you into brand new breakout groups, so make sure you see what group number you are. And the slides below are your space to put all of your representations. The problem's also on the left-hand side if you need to reference it again. So let's go ahead and get our thinking groups together. Alrighty. I'm going to go ahead and start them automatically, so just turn on your mic. We'll see what group you're in, and you can head down to your group slide. Here we go.
Lisa. Hi, Laura. How are you?
I'm doing okay. How about yourself?
I'm doing great. Gorgeous weather.
Is it now? It gets really chilly up here, so I'm glad to know somebody's having a good weather day.
We had I'm in Texas, so we had that horrible spell, and it's been nice this week. We did have a cold front come through yesterday, but the wind is not blowing today, so that's nice.
I'm glad. It's the little things.
Hey there.
Hi, Teresa.
I just wanted to check in. I saw that Rhonda is signed in 2 accounts, so I made sure that they're both in here so you don't hear feedback. But if you do get any kind of feedback, just make sure you only have the one mic on, Rhonda, and that'll make sure that doesn't happen.
I'm sorry, I had to reset my settings, so I logged out.
It's perfectly okay. I just wanted to make sure you knew what that was in case you have any troubleshooting.
No, I'm good. Thank you very much.
We're on slide 35. We're group 6.
35. And the question is to the left usually, right?
Yes.
Yep, there it is.
So it's 2 friends, and they have to eat leftover pizza. So I'm going to check the...
Hi there, group. What's everyone thinking about doing for their way of thinking of this problem?
We were still thinking about it.
Oh yeah, definitely. Take your time to
We haven't
think.
talked about it.
4/6 half of a mushroom. And what's that last pizza? 1/3 of a sausage pizza.
Yes.
Okay. So oops.
It's a good idea.
That one, I don't find that one to be as friendly as a tool.
Which one? The Math Learning Center?
I don't find Math Learning Center to be that friendly for kids to work with as a tool.
Yeah. Well, I haven't used it before, so.
Yeah, it's like it's so much that they have to set up before they can actually use it. Okay, so she got Math Learning
I mean, that's
Center.
fair.
Oh, she got the Math Learning Center, the line, the number line.
How does this? Ah, okay, that's how that works.
Yeah.
And say, how much in total do they get? So there's some choices. So if you have 3/4 of a pizza,
Good morning, Tamara. How are you?
Good morning.
Hi. Oh, and am I saying your name correctly?
I'm Tamara. Good
Tamara. Well, it is nice having you here. And what we've done so far, we're in groups working on a math task. So let me give you.
Okay. I just was coming to observe. Wasn't too sure what it was about, so I just said I would join just to yes.
Perfect. Well, glad to have you here. What grade level or what is your job? What do you teach? What do you do?
I'm a new principal.
Oh, for elementary, middle, secondary?
For elementary school, yes, elementary school.
This problem is perfect for elementary schools. So I just gave you the link to the slideshow, and I'll kind of give you an introduction, and then I'll put you in a group with some other folks who are solving it. So the problem starts on slide 29 is where we are, and Julia and her two friends are finding leftover pizza, and they're figuring out how to share it evenly, how to partition it. And so you can see after slide 29, groups have started to kind of model it in different ways, and they're thinking about how Julia and her friends can share this leftover. And that's just about where everyone is right now.
Okay.
So I'm going to put you in a group, and I'm going to come down with you. And in group 6, we've got some amazing teachers down there, and you can talk it out, you can add to the slide, and more.
Okay, so let me, actually, I'm sorry, let me join with my laptop. I joined with my phone because I didn't know it was so interactive.
Oh, yeah. I am very interactive. Yeah, go ahead and log in with your laptop, and then I'll move you into that group.
Hold on 1 second.
So I accidentally clicked on yours. You have to re-click on it.
All right, so it's, what do we got, 3/4 pepperoni.
Hi there, Group 6. I just want to let you know that Tamara is joining you. Just getting a different computer, and then we'll be on. And Tamara, we are on slide 35. Ooh, love your model.
Thank you. Thank you. Good afternoon, everyone.
Hi, how are you?
Hello.
Hello, pretty good.
Hi, Tamara. Is it Tamara or Tamara? Tamara?
Tamara. It's okay.
Tamara. Okay, Tamara.
Mm-hmm.
Welcome. We're going to go back to slide 35. We're just making the...
Thank you.
We just got to figure out how to describe 2 ways that the girls can share the pizza so that each gets a fair portion. You are encouraged to use pictures. Models and are virtually going to take pictures and post.
Okay, so I'm thinking that between the half and the fourths, they can have the mushroom pizza. My Google Slides are really bad. Okay, so they can have that slice of mushroom pizza to get the fourths.
Okay.
Right? But then they would have to have
two friends.
They would have to have the thirds to get a sixth of the sausage pizza. So essentially they'll have a fourth of the mushroom, a fourth of the pepperoni, a sixth of the cheese, and a sixth of the sausage. I don't know if that makes sense.
Yeah, it does. Because if you're doing a half, it's easy to split up the half and the third because they equally split into halves easily.
Right. The other one that I was thinking,
3/4 divided by 2. So they're each going to have to get. You're gonna have to do 3/4 in half. So you'd have to do, like 3/4 in half because they're each going to have to get.
I see what you mean. So what I did, I kind of changed my idea of a whole. So I'm thinking that this is the whole pizza over here for the sausage. Let me shade it in 1 minute. I'll actually do it in black. Nope, that's the opposite of what I wanted. Sorry. So I'm thinking this is a whole of the mushroom pizza, and this is a whole of the pepperoni pizza, because the question didn't say the pizza had to be, all of it has to be eaten up. There might be leftovers.
Oh, okay. So there might be leftover.
Right? I mean, it doesn't say. It just says that they have to fairly eat it.
Right, so one can have more than another of a certain kind.
Right, exactly. But that's just one way. Because we have to describe 2 ways. Definitely the fourth slices are going to be bigger, so they'll get a bigger slice of pepperoni and mushroom, and a smaller for sausage and cheese. I don't know if does that make sense? Okay,
yeah.
Alright, so I'm going to write one scenario down.
A fair portion. So it didn't say exact portion. It just says a fair portion. So you could also say they get a certain amount and then some of it's left.
So if we split everything up into 12ths, then
I like that strategy.
I'm going to say,
All right, if you are watching this part from the recording afterwards, this is a little bit of what's been going on. First of all, I use the 5 practices, Smith and Stein's work, for deciding how we're going to have this discussion in a moment. And I anticipated several ways people are going to solve this, including changing the problem to make it a little bit more vague so that it just says fair. In this case, group 5 has figured out that fair means that everyone gets half of a pizza, so they're not really caring about the pizza topping. And then what would be left is a quarter of pizza for each of the other folks. And I would ask them to kind of explain how they knew it was a quarter left over. And so this is one interpretation of it that I want to bring up. And then we get into, well, what if they're different flavors? Let's make sure everyone gets a fair amount of flavor. I saw one group starting off by making a table. I want the whole class to interpret the table and then complete the table. I'd also like them to see that sometimes our partitions, if they're fourths and there's 3/4 there, that's perfect. But sometimes when there's 4/6, that they need to split it up into 18ths. And then there's 2 more, which I use the crop function so that later we can reveal what it is to split that into equal parts. And I've done that for mushroom and sausage. I think I'm going to take this one here out, because on the next slide, I want them to talk about, why 12 is really awesome here. Like, what is so great about 12? It's a common denominator that all of those pizzas could be cut into and then given out in that case. And we can see that these fourths easily splitting into thirds also, giving us 3, 6, 9, and 12 for the whole. And then we can also look at the connection between the 3. We're going to sum up with the representations that this group did, because it really connects over to fraction tracks, which was our earlier game talking about how to split up fractions and then add them together. And unfortunately, I'm falling into the trap that many teachers do when you have too many really awesome things that you want to share. And now I've got to narrow it down. So I've got every flavor. I've got this kind of interactive slide. This group is doing a great job at slicing them. But I think I'm going to take that one out because I really want to focus it in just on a couple. All right, I'm going to give them their 1-minute warning. To do that, I simply put a little text box and then I just paste it on the other sides. It's a nice way to give them a heads up, and I don't totally disrupt their thinking. Hello and welcome back.
On YouTube.
Hello everyone. Welcome back to the main room. All right, I have already muted you just to try and respect your background as you're coming back. All righty. Welcome back to the main room, everyone. It seems like you all were really engaged in this problem. I'd love to share out a couple of them using a strategy on slide 36 from Smith and Stein, where ahead of time, not only have I anticipated different ways that students might solve this problem, but also different manipulatives, and I've learned so many more thanks to you all. I've monitored, you heard me come into your room, ask you about your thinking, identified some specific strategies or some models that I'd like to show. And then I've selected and sequenced them, and now we'll have our whole group conversation. And we're going to start off on slide 38. I'm hoping that someone here from group 5 can tell us a little bit what you were thinking about and how the three girls share the pizzas.
Hi, this is Stephanie. So someone started off with a common factor of like 12ths, and I was like, I didn't even get to that point. I was thinking visually. So we first started with creating each of the pizzas into like a visual pie chart. And so my group mates were working on like creating those common factors and common denominators. And so I thought about it again more visually, where I automatically saw 1/2 of the pizzas could be shared equally between 3 students or 3 people. So I automatically divided those between the 3 people. And so then we had 1/4, 1/6, and 1/3 left. And so I then added those pieces together. I broke it down into steps of 1/4 plus 1/6 equals 2/6. So then I added 1/4 plus 3/6, which I converted back to a half for 1/4 plus 1/2 equals 3/4 pizza pies.
It's so neat. All right, so here we've got a way where it almost doesn't matter kind of if we have 12ths or not because of the way that you chose to split this. I'm curious, did anyone else think of doing it this way? Do you wish you had done it this way? Do you like one particular piece of pizza more than another? Feel free to voice your thoughts there in the chat.
Yeah, I like to kind of look at this one and sort of think about it practically and think of, given these numbers, how would the pizza have been divided so that you could actually be left with these various fractions. And so that's where I think 1/12 comes from, because that's the logical breakdown that this would have been in 12ths.
Yeah, exactly.
And I think also if you're going to think in terms of if each one gets the same portion of pizza, which was the other solution we had, then you have to start thinking, is that possible really, and how would you do it? Because then you're dealing with 9ths, which is not going to be the way it's currently split up most likely.
Yeah, and it works really well if, like Laura said, if everyone else ate all the mushroom, because I guess Lisa does not like mushroom. But in some cases, it starts to matter over what type of topping you like. And the next model on slide 39 really brings a lot of great ideas to these other models. Now, this is actually taken from 2 different groups. So group 2 started this table, and it's not complete. And what I'm going to ask is anybody who is not a part of group 2, feel free to add something to this table. We'll see if we can make a whole class table. But as that's happening, I would love to hear from group number, oh goodness, who did this one? Group number 3, about your different models. And I've broken this apart into 3 pictures because I kind of want you to explain, like, step by step how you knew how much each person would get. So who did this one? Who can explain it for us?
Teresa, are you talking to group 2 or group 3?
Let's see.
I'm
Oh, I'm sorry. It was group 4 that did this one. Here we go.
Okay, I made this one, so
Yeah.
I took the pepperoni, and I made the assumption when they said 3/4 left of the original was cut into 4 pieces, so I showed the 3 that were white. But the really big one, the cheese, and some of mine got cut off, I think.
They did. I kind of did that on purpose. Talk me through it, and I'll reveal them.
So the cheese pizza, there were 4/6 pieces, so I showed the 4/6. So each kid would get 1/6 of a piece, and then you take that extra piece, the blue one, and cut it into 3 smaller pieces. So those 3 smaller pieces are now 1/18 each. So each kid got 1/6 of the cheese plus 1/18 of the cheese.
So 1/6 plus 1/18. Okay, I've got that, and now I'm gonna slowly reveal the next ones as you chat them out. So tell us about mushroom.
I want to say something
go
real
for it.
quick about that cheese. I just think a lot of kids, younger kids, they're going to separate equally what they can, and then they'll cut the leftover, like that one leftover piece, cut it into equal pieces, with candy especially.
Yeah, absolutely. Yeah, they just keep wanting to divide that up.
Right.
So then
Okay,
how did
so
you do mushroom?
So I took the mushroom and I cut it into 3 pieces. So I found an equivalent fraction where I had 3 pieces, which you just revealed. So each person would get 1/3. No, I can't even see the number now. 1/6 of a mushroom pizza.
Awesome. And I kind of like that you said 1/3 and then you went, oh, a 6, because that kind of is that idea, like 1/3 of 1/2 is 1/6. We just kind of did that, like that operation there. And how about our last one? What's going on down there?
And I did the same thing. I cut it into 3 equal pieces. So the third of the pizza became 1/9 for each child or each girl to get.
And then we can go ahead and reveal it just to see that 1/3 of 1/3 is 1/9. So now we're getting into fractional and multiplication. And I see that people are making those comments right over there on the side with our table too, which is fantastic. Did anyone make any aha moments, connections with our table as Gail was talking about the visual? I find it interesting that Gail said cheese is 1/6 plus 1/18, but these numbers are not in 6ths or 18ths. And that's just interesting to me. I would start to wonder why.
That wasn't me talking on that one.
Oh, sorry about that.
That was Lisa talking.
Lisa, thank you. Yeah, so why does the green arrow have 1/6 plus 1/18, but yet here we have 9ths? How does that happen? So in order,
Obviously,
okay,
if we convert our 9th, no, our 6th into 18ths, we have 3 18ths plus 1/18. So that gets us, when we add those and get 4 18ths, that simplifies to 2 9ths.
Awesome. Alrighty, so we're getting into this kind of simplifying thing, which was what Fraction Tracks was all about, indeed. And then come on down to slide 40. Many groups found this magical number of 12. 12 was just on everybody's screen. What on earth does 12 have to do with this problem? And if you were the creator of this first model with the arrow, can you tell us why you broke them down into pieces of size?
I don't know if that's me, but that's what I did when I was putting it together. I was trying to find something that made sense for all of the pieces. So finding the common denominator, which looking at them all came to 12. And then I wanted to show the equivalent of that. So, if you've got, 1/3, what would that be as a 12th? And so I was showing the pieces. We actually talked further, and I'm sorry, I forget her name. She was talking about how she could see how that bottom piece down there of sausage could have moved up into the cheese area and made a complete pizza of 12. So she was using, my visual to try and, complete her visual and seeing how those pieces could be put together to make a whole.
Oh, very cool, Jennifer. If that was you, can you tell us why did you choose to do that? Why did you move the purple into the yellow?
Oh, it's me. I'm Remy. Because I'm trying to get the connection between the table and her visual representation. And at that time, we already know that each person will get 3/4 of a pizza.
Mm-hmm.
Oh,
is that what you were thinking, or am I doing something different now?
The one on the right, the 4 purple pieces.
Mm-hmm.
So if you look at the green on the right, you have 3 space to get to 3/4 of a pizza. So I moved the 3/4 of the purple on the bottom to fill the 3/4.
Let me see if I'm doing this right. Let me know if this is it now.
Yes.
Okay. All right. For those of us that need to hear it one more time, tell us again what's happening with that purple.
We were trying to tie the table, how we use the table to find out 3/4 for each person. And then I tried to tie it to the visual, saying that how can I tell that each person gets 3/4 of a pizza? If the pizza cut into 12 pieces, so I can see that the bottom one, the purple, I can split 3 pieces and then fill into the green, and then 1 piece fill into the yellow. Then I can see each one of them get 3/4.
That is a really powerful image of splitting that sausage and kind of giving that one out. Thank you, Remy, for sharing that.
Oh, you're welcome. We also say that what if a student doesn't want whatever pizza, and Jennifer get a great suggestion. You have no choice.
I love that one.
What you get.
And we also have models like this one here. This was just such a neat model because, you know, so often we show circle diagrams or area models with circles, but this one, just because of the number of pegs, I love that you could see the splitting, like if you were going to have to cut it into other pieces. Oh, and someone put the link in there. Thank you if that was you. And that brings us to our very last group. I've put down slide 41, which first interested me because this looked a lot like fraction tracks. But I think you're going to maybe want to use slide 42 to walk us through it. So if this was your group 1, can you tell us how you were thinking about these fraction pieces?
Hey, Teresa. I think the thinking along the bottom kind of matches that first image that you had, which is right there, the second one on the bottom. So the first fraction strip image on the left on the bottom was building up the value of each pizza based on what it said in the problem. That second one is where everything was combined. So like the first 2 lines of that model show if you if you take the fourths and then you could see the 4/6 and the half, and then the 1/3 wouldn't fit. So the 1/3 was converted to 12ths, and then you could see the 1/12 could fit at the end of that line, and then 3/12 could fit on that second row.
I see.
So it was more like adding those fractions together and figuring out how to make a whole, and then how much was left over, which was the 3/12.
So you kind of lined them up in a nice long strip.
And then the third image over was then just recognizing that you could show it in all 12s to figure out what the total was. So if you converted those 2 wholes plus the 3/12, you'll see it's 2 and 3/12. And then that fourth image where it says each person gets 9/12, that, yeah, right there, that was basically fair sharing all of those 12s to figure out what portion of the whole each person could get. That's kind of a walk through the thinking on that slide, at the bottom at least.
That was a really nice walkthrough. Thank you for that. So yeah, now we've kind of put it all out in a long line. And I could almost see this happening because I have been, someone who will support like swimmers events where we have lots of plates of pizza set up on a picnic table. And I can say, all right, these are teeny tiny slices, but you can go pick up 9 of them. Go get your favorite toppings. And so I can kind of see that linear model in that situation also. All right, folks, we are closing out our hour here. What I hope that you see is that there's a variety of different ways that we can partition this, especially when flavor doesn't matter, and then when flavor does matter, how we can make sure that each of the groups get an equal number. There were tables, there were visuals, there were area models, linear models, set models, and more. All these different models can help our students to make a lot of great connections. And they, of course, connect right back up there with the fraction tracks where they are breaking apart fractions into equivalent fractions in order to win the whole or the whole pizza in this case. So I hope you found this useful. If you have questions, I have many that are frequently asked down on slide 43. But otherwise, I am willing to stay on as long as you all want. If you have questions, you can put them on slide 44. If you want to see other topics and grades, let me know. But otherwise, happy MATHurdays, and can't wait to do math with everyone next Saturday. Peter, we really do make a lot of connections, and I think probably one of the biggest challenges as a facilitator is the timing to get all, I wanted so many to present, and narrowing it down to just a couple is so challenging. Yeah, what were your favorite connections that you made?
I really was, I'm a paper kind of person, and so I was working on the paper while everyone was up on the screen, and I need to get more with but I was amazed at Remy, she, and how you actually picked on her a little bit, but how she did her explanation. I was in her group, and it was really neat to listen to the reasoning, and also the interaction among the different participants, and I really thought it was really nice how they would say, "Oh, I didn't think about it that way. Did you think about this?" Or "I was thinking of it this way," and I was like, "Oh my goodness!" And I was trying to, and I know it's on the slides, but I was trying to write down, and I had pictures and all kinds of crazy silliness on my paper, arrows and stuff. So anyway, I probably said too much.
Oh, that was perfect. Peter, I actually do a lot of paper pencil too, and I'm not willing to get rid of my paper pencil even for online. So I'll showcase what I do. And this is also for the recording, but if I want to bring my paper in, I will go to Insert Image, and then I'm going to hit Camera, and it turns on my webcam. I hold my work right up to it. Click a picture, say Insert, and then I crop it from there. And I mean, you can clearly see that I love paper pencil also. I'm not going to be getting away from it anytime soon, but that my thinking can still be valued on this slide, and it can be shared with others. If your students do this, I highly recommend marker as opposed to pen and pencil, but even if they are using pen and pencil, they can still get it up there.
My group had suggested that I was kind of quiet, and I realized my microphone was off, but I wasn't drawing on the screen or whatever. But they were kind enough to prompt me to ask questions, and I was grateful for that.
Sounds like you all had some great collaboration. Thanks for sharing. Somebody asked, how do I make the arrows to move around the slide? There's a couple of tips that I do classroom management wise for just getting our attention there. Because the arrows are in the shapes always, I use these very frequently. If I have a lot to type, I like the little call out arrows also. And so I can put more here. If I don't like the font size, I can just reduce it. And you know, I can even change the color. So if I have multiple things that I'm talking about, I'll say, hey, look at the yellow arrow. I'll keep that information. And then I'll say, hey, look at the green arrow. I'll keep that information. And then, you know, come on over here and look at the blue arrow. So those are all just the arrow tools.
A quick question, but does it automatically give you the text box inside?
Oh yeah, all of the shapes give you the text box inside. So, you know.
So you don't have to actually layer a text box on top of it. It's already built.
No. So if I want to use the heart and put the word love in it, it's already got a text box available for you to write.
And when you're moving it around, does it have like the little, you know, change size little, you know how it looked before you click off of it? When you're using it, does it look like when you first make it with the, you know, with the rotating, you know, little thing at the top?
Yeah, so there's a couple different settings that you'll see. There's the moving setting where you have the crosshairs. There's, if you double click it, it's the cursor, and now you can type in it. And then there's the 2 arrow where you can stretch it out.
So wait a minute. So you're saying when you have the shape, what happens is when I make it, I click on it, and then it gets rid of those things on the outside?
Yeah, if you double click on it, it'll let you type in it. I can't remember if it gets rid of the things on the outside when you double click. I think it's still.
So can you see, like I just put it on, see over in the white space, can you see, like, you know, the outside little boxes that helps you change the shape and size?
I cannot. No, I see that you've selected it because it's pink, but I don't see your blue outline.
Okay, so nobody sees that except for the person who creates it.
But I can click on it and I can make it appear. So I can click on your arrow and I can stretch it out.
Right, and then I can move it around. When I move it around, it just looks like an arrow, but it doesn't have those outside, you know, support things on it. I don't know what they're called. Okay. All right, that's what I always wondered, and I didn't realize that it automatically gives you a cursor inside. Thanks, that really helped a lot. I appreciate it.
Yeah, and you know, Naomi, that cursor, if you are trying to engage more students in the discussion, specifically your students who you know are really great thinkers but might not be as comfortable with the microphone, I might say like, hey, Naomi just said this great thing. Hey, Lisa, would you rephrase that in the arrow just so we don't forget it? And so that gives Lisa a job to like rephrase your thinking right there in that arrow. Lisa can showcase, you know, her understanding of this there. I don't have to do it. I've just given that to my students to do, and then I can continue the conversation in a new like area.
Oh, so we would just leave that arrow with the rephrasing and then create a new arrow to move around to whatever we want to talk about. Oh, that's so good. That was great. That's why I love these Saturday sessions.
So Naomi, click on your arrow and hit Control D. Unless you have a Mac, then Command D. That's the duplicate button.
Yeah.
It will just, it'll make, especially if you've resized your font, it makes it so nice and easy. Yeah.
Yeah. Oh, I always forget Control. I always do Control C and then Control V, but Control D, right? I always forget that.
It preserves your text size. So like when I said put one here or put more here, you notice that it decreased the text size, and I didn't want to have to do that each time. So I just Control D'd it instead of making a new one.
Got it. Okay. All right. That's like Control C, Control V, but you did it in one step.
Exactly.
Okay. That was great. Oh, you made my day.
You know,
again.
these little tricks, some people call them tricks. I call them classroom management hacks. Yeah. Ooh, I've got to remember Pythagorean Theorem. I have a great little activity for that one. So somebody wrote, how do we make sure we get every student's thoughts heard? Some of the strategies that I just discussed there by, you can make physical spaces for them to have their voice heard. And one of those spaces, for example, if I go over to the templates, I'll sometimes ask them.
Own a space.
Yep. I'll ask them to put their thoughts in a certain graphic and then share all together. So there are some things that if you're working on, and how do I get them to talk to each other? Here's an example. I'll just stick it in our MATHurdays slides. So on the slide above, I might put like Andy's got to put their stuff there, Raha here. I didn't spell that right. How am I? Let me fix that. Rahah. One more H. There we go.
Thank you. Also, you can do no wrong in my eyes, Teresa. If you want me to spell that way, I will change my name.
Oh, names are such an important thing to me that I always want to make sure I get it right, even if someone pronounces it a little different than how I'm used to hearing it and spelling and all that. So in this example, for the person who wrote that, if I'm working on getting my kids to actually talk to each other, then I'll say, all right, on this slide, everybody puts their summarization first on their own. And then when you see other people's on there, you can start to bold it if you really like their thinking, and then you have to start to talk about it. And then as a group, you make a summary, and this summary is the one that we share out to the class. So everyone's got an independent part, but it forces collaboration to make that summary part. So those are little strategies that you can use if kids aren't talking yet. Somebody asked this about how do you make breakout rooms. In this setting here, I make them anonymous, and I make it so that we have about 4 people in it. I've been doing some things recently just to support me with the management system here, and making sure that if I have people who come regularly and I know that they know the Blackboard Collaborate system that I'm using, that I have like at least one of those people in each room, that can help me out. But I do the same thing in classrooms. If I know I've got some techie students that really like the techie stuff and they're calm with it, I make sure that they're dispersed also. All right, I'm gonna go ahead and look at future Eventbrites and start to assign some of these so that you all know when they're going to come. So let's see, we've got, let's do the Pythagorean Theorem one next week, because we just did a kind of more of elementary this week. So the 27th, we'll do Pythagorean Theorem and really focus on middle school. Okay, so Joanne, next week we'll do that one. What is that, the 27th? Kathy, if you're still on, what kind of division? Oh, you're, I don't see you on here. Never mind. And then we'll do mean, median, and mode. I'm going to throw range in here too. Stephanie, are you still on? Nope, no worries. I'm going to put that one on the next one. All right, folks, I'm logging off. Have a great Saturday.
Thank you.
Thank you, Dr. Wills. I just posted one more question for you if you're still here.
Oh, yeah. How do we support students if they're getting spoken over? So there's a whole lot of classroom dynamics that happen even before you get to these tasks. And I typically look at breakout rooms and the structure for them. And this is a structure that I'll show you here. There's kind of a lot of teacher support that happens ahead of time. And so this slide that I'm referencing is on 45. Right now today, what we did was a little bit of phase 1 and a little bit of phase 3. And I'll be very explicit here that in phase 1, when we did the fraction tracks game, you were in a small group for just a little bit amount of time. And I'm checking for things like, are people using their microphone? Are they being kind to each other? Is there a safety protocol, like how to use the internet safely? And are you implementing some of the norms? It's after I've checked in on these things that I can move to this third phase. This third phase isn't just magical, and you can't throw kids in it unless you know that they have, been equipped with the strategies before it. So looking at different phases, such as giving equitable talk time, that can be done, especially if you used roles. I don't have them in here, like a nice role is being the mayor, where that person's job is to make sure that like each person, their voice is being heard, that they're valuing collaboration. These are traits that I actually go into breakout rooms and I listen in on, and I train students how to do that before I put them in that third category there. Does that help explain it?
Like, it makes sense for, I guess, for when you have a more regular group of students. The reason why I was particularly curious about this was when we did the first group, I felt like I was that student that was very confused, tried to ask some questions, and was spoken over too often for the question to get heard. So that's why I was curious, like, how would you help students that were in a similar situation?
Yep. So that would be in that very first phase. So what I do is I keep a running record of my students and where they are, and I only move them to another phase when they've gotten there. I can show you an example of a running record here of like what I would do when I have an established group. Let me just get it open. And these running records can be used for anything, for seeing which of your students know how to multiply fractions. It's kind of like a list where you check people off when they've mastered something, so that you know which ones you need to still look for evidence of mastery. And I know I've got one in this slide deck here, so let me just take a quick peek.
Thank you, Dr. Wills, for taking extra time to look into this question.
I just have too many. All right, here we go. So on the MATHurdays slides, slide 46, I have an example of a running record. So I can look real quickly and see from my record who is comfortable with like resizing text boxes. Once I have everybody in my class comfortable with them, then no big deal. Like, I move on. If I see that there's only evidence that a couple people know how to move something, then I might do a session on that with a small group of students, or might go into that group and say, Meg, I'm noticing that you're doing most of the talking in your group. How about this time you be the mayor, and your job is to make sure that everyone's heard. And I'll keep checking in on your group that lesson. And when I see that, you've been doing more equitable talk time, I will check you off on my running record, and I'll know that you know that skill. So that's how I check in on students and teach them individually or in a small group.
Thank you. Yeah, it's it can be tricky balancing it, especially when we're not in a face-to-face setting where you can't see as easily as somebody's being too quiet or trying to talk or something like that. So it's interesting to hear about some ways to help in a virtual setting because it's more of a new environment, and I really appreciate the extra guidance there. Also, I appreciate that you spelled John C without a H. That's my dad's name.
Oh, nice. Yep.
So thank you,
Sure
Dr.
thing.
Wills. I hope you have a great day, and thanks for a great session.
Dan, you mentioned how do you recommend building on previous knowledge. Tell me a little bit more.
Yeah, so like for example, I sent you the email a couple weeks ago about multiplication tables, and how for that one you can use that model to teach so many different things. For example, sequences and series, you wouldn't necessarily want to teach that right away when explaining basic math in terms of multiplication. So how do you recommend taking a concept and then coming back to it and showing how, like for example, law of cosines is just a more powerful version of the Pythagorean theorem?
So I really like looking at tasks and the way that tasks relate to multiple grade levels, because when I hear multiple grade levels, I don't think of just like, hey, you're a third grader, this is what you know. Instead, I hear it as like a progression. So when it comes to Pythagorean theorem, in fourth grade, kids have some prior knowledge about things that are right triangles and triangles that are not right. And, then they get into middle school, they start to learn about Pythagorean theorem, specifically in the lengths. They get into high school, they get into, upper level mathematics, and they get into this idea of law of cosines. And so when we give them a task that maybe they first have to figure out how to use the Pythagorean theorem in a situation that's not a right angle. Like, should this other number be higher or lower, and how does that react? That's going to kind of get you into those other zones. It's not a discrete standard anymore. It more fits on this kind of continuum or progression.
Interesting. Yeah, that makes sense. Yeah, and you can also essentially start with something that's a right triangle, then something that's slightly off, and then you can start with approximation. And then, yeah, I can see what you're doing there. As well as you can say, use the law of cosines to solve, and use a situation where obviously the Pythagorean theorem is more direct because it's a right angle, and then you can show, okay, cool, yeah, I can see that being very helpful. Thank you.
So is it next week did I assign for Pythagorean theorem? Let's see. Yeah. So what we're actually going to do, this task that I absolutely love doing, is using the Pythagorean theorem, but we'll never, ever use a right triangle. And most of the time when you tell math teachers that, they're like, what? What do you mean? Pythagorean theorem, you have to have a right triangle. Like, actually, it works great for others. It just works in this very perfect way for right triangles. So we're going to kind of investigate the other ones and how we use it in those situations. And that brings it, instead of being a discrete standard that's only taught in one grade, it branches it out into multiple grade levels.
Interesting. I'll definitely have to see that, because I'm not sure how you could use it without it being the law of cosines. So I'll have to find out what you're talking about. That sounds very cool.
All right, then. I hope I see you next week.
Yep, see you then.
All right, folks, have a wonderful Saturday.